Hi, in this video we're going to look at the laws of logarithms. Now, when you dealt with exponents last year, right, in this video we're going to look at the laws that relate to logs. Just as we had with indices, we had laws of indices, so we're going to have laws of logs, and it's really important that you are familiar with these laws. So, the first of the laws is this. If I take the log of a product, two numbers together, that is going to be that will result in this situation. It's going to be the log of A plus the log of B. Let's take an example of this. So if I go and take the log of the number 6, get the calculator and take the log of 6, and that comes up with the answer 0.778. What else was there? 151 da. Now, we're saying the log of 6 is equal to that number. Now, according to this law, a log of 6 is the log of 2 times 3. So in other words, I could write this as the log of 2 plus the log of 3. Let's see what happens when I go and punch those into the calculator. So the log of 2 plus the log of 3 gives me that number there. And if we compare those two together, we can see that they match up. So the log of 2 is 0.3010 plus the log of 3. Log of 3 is 0.477121. 0.477121 . And there we have it, the first of our laws. The log of a product can be written as the sum of the two factors, log A plus log B. Now, allied to this one is the second law of logs, and that's the log of a quotient, so the quotient of A over B. Now, if the product was a sum of logs, the quotient is going to be the difference of logs, so this is going to be the log of A minus the log of B. So we know that the log of 6 is equal to 0.778151, So I could, and we know that the log of 2 is equal to 0.30102, So the log of 6 over 2 is simply going to be the log of 3. Now, log of 6 over 2 I could write as log of 6 minus log of 2. Let's check this out in the calculator and see what we get. The log of 3, there it is on the screen. The log of 6 minus the log of 2. We press it and we see we come up with exactly the same answer. So here is our second law of logs. The third law of logs is one that you're going to use quite a lot. It's a really important one. And it's this. If I've got the log to the base A of a number, and that number is raised to a power, then I can rewrite this as n times by the log of A to the B. We'll look at an example of this to see how this plays out. If I go and say the log to the base 2 of the number 8, well, 8 I know is log to the base 2 of 3. And so according to the law that we've got above here, we can rewrite this as being 3 log to the base 2 of 2. Log to the base 2 of 2 is going to be 1, so that's just simply going to end up as being 3. However, I could also have written log of 8 as being the log of 2 times 4. Now, using our first law, we'd have had this as saying the log of 2 plus the log of 4. And that I could write again as being the log of 2 plus the log of 2 times 2, which I could rewrite as the log of 2 plus the log of 2 plus the log of 2. And that would end up as 3 of these things called log 2. And so we can see that statement and that statement are the same. I should have put my little bases in here. And once again, that would simplify down to 3. So there's our third law, and I say that law we're going to use quite a lot. It has a slight adaptation as well that we can look at, and that is if I've got log of the nth root of a, well, that I'm simply going to rewrite as being the log of a to the power 1 over n, and that's going to be rewritten as 1 over n log of a. That's really just using that power rule for logs. So there's the third law. And then the fourth one isn't so much a law as a useful adaptation. And that is to change the base of a log. Now, sometimes they will tell you what the base is, other times they won't tell you what the base is. So if you see something that's written like this, log to the base 2 of 5, that means you're working with the base 2. However, if you see something like this, just the log of 5, we understand this to really look like this, log to the base 10 of 5. If it doesn't have a log written down there, we understand it to be the log 10. And it's your calculators that work with log 10. And so it's really useful to be able to, I don't want that. It's really useful to be able to work with the base 10 because that is what our calculators are tuned to do. So how do we go about changing this one up top over here? How can we calculate that on our calculators? And there is a way in which we can do it. And to do that, we need to look at this basic principle. So if I've got log to the base b of the letter a, then I can change this to being log to some other base. I'm going to call it c. It's going to be log to the base c of a divided by log to the base c of b. This means you can determine what log you want to work with. So if we go back to that example that I put down earlier, log to the base 2 of 5, I can't do that in my calculator because the calculator doesn't work to base 2. But what I can do is I can say, right, this is going to be log of 5 divided by log of 2. Really, we should have a little 10 over there so that we can indicate that we're working with our calculators. But if you, as I say, if you leave it out, it's understood that that's what's going to happen. And then obviously you can just get your calculator out, clear all of that, and then it's just a case of log 5 divided by log 2. And we get our answer there, 2.31. 2.3, was it 2 or 1? 2.32. Just be careful. Log of a divided by log of b is not the same as the log of a over b. that is a very different thing. Remember this, log A over B, that's your second law. That's log A minus log B. Different to the log of A divided by the log of B. Enough of my chatter here. You need to now go and practice some of these on the exercises.